welcome everybody. My name is Aaron Weeden. I work for the Shodor Education Foundation. We're part of the education program for the EXCEED project, which stands for the Extreme Science and Engineering Discovery Environment. And it's funded by the National Science Foundation. And at Shodor, we also run the National Computational Science Institute, or NCSI, or NICSI. And we're excited to welcome you today to this workshop on computational thinking across the curriculum, with a focus on using spreadsheets and web resources. And before we get started into the main content of the workshop, I wanted to just read a couple slides to you quickly here. So I'm going to share my screen. And so EXCEED has an external code of conduct that we'll be observing during this meeting, which represents our commitment to providing a inclusive and harassment-free environment in all interactions, regardless of race, age, ethnicity, national origin, language, gender identity, sexual orientation, disability, physical appearance, political views, military service, health status, or religion. And the code of conduct extends to all of EXCEED's events, services, and interactions, including this workshop. The full code of conduct can be viewed at exceed.org/code of conduct. And if you have any concerns about anybody's conduct during this workshop, you can either contact the organizers, who are myself and Bob Panoff, or any of the ombudspersons through EXCEED. There's also an anonymous reporting form available. And in line with the code of conduct, EXCEED is also committed to providing events that are inclusive in terms of terminology. So any of the materials we use today or anything we say in the presentation, it's not our position to use, condone, or promote offensive terminology. And we're striving to keep inclusive language at the forefront. So if you have any issues with what we say or have used in our materials today, and if there's anything inappropriate, we'd like to know, and you can contact terminology@exceed.org, which is the terminology task force. And if we do use any third-party documentation, while we don't have any control over their terminology, we are taking steps to contact them, and hopefully they will address concerns soon. But if you do see any concerns about code of conduct or terminology concerns, you can get in touch at terminology@exceed.org for the terminology task force. Okay, so I'm going to stop sharing my screen now, and I am going to turn it over to Dr. Bob Panoff, who is going to be leading us in this workshop. So over to you, Bob.
Thanks, Aaron, and thanks to everybody for being here. My goal today is to sort of spend today and tomorrow looking at spreadsheets and primarily using Excel as an example, although many of the examples will work with Google Sheets or with numbers. Not all of them will. They're completely separate programs. They do the calculations differently. They make different assumptions. They have different functionalities. So to make my point that everything I wanted to teach you about computational thinking, I could teach you using a spreadsheet if I had to. The goal of this particular workshop, especially today's content, is to show you that you could teach an introduction to computational thinking at the introductory level without requiring an extensive knowledge of programming, because the purpose of using Excel as a sandbox, as a place which it's safe and easy to play around in, is to cover the programming concepts so that when you do get into an actual programming course, the students will already know all of the basics, at least the vocabulary. The analogy I've used several times, it's like when band instruction came to Northern Virginia, all of the 4th, 5th, and 6th graders could be in the band, and we couldn't wait to be in the band, but my parents put a block and said, you have to take 1 or 2 years of piano lessons first. And of course, with 5 boys in the family, my father was convinced that none of us would take the piano lessons so he wouldn't have to buy band instruments. But what it turned out is that not only taking the piano lessons didn't deter us, it actually gave us an upper hand advantage. Because when I was learning to play one note at a time on a band instrument, I already knew how to read notes, how to read music, scales, tempo, time, transposition, music theory. I had already learned what octaves were. I already knew what tones were, overtones, where every other kid in the band was learning how to play their instrument and how to read music, etc. So I hope what you'll see is that there's lots of ways of introducing programming concepts. And what we're going to cover today is just one particular way of doing it. We're going to do some more advanced stuff tomorrow, especially with computing models that are much more extensive. Today, it's going to be sort of the atomic and molecular pieces of the programming concepts, and I hope you'll get some sense of what we're doing there. I'll be using 3 platforms. I'll be using you looking at me, well, maybe 4 platforms. I'll have my slides that are actually a web document, not a PowerPoint. The code name for this project is Beyond PowerPointlessness. So we don't use PowerPoint for very much, but it's all web accessible, should run in any browser. I'll also be using my iPad as if it was a marker board at different times for going through things like that. Depending upon how you have your screen set up, you may want to just watch what I'm doing. You may want to do it along with me, or you may find yourself not quite able to because you don't have Excel, or your version of Excel has changed or hasn't changed, depending on how old it is. Microsoft, I have to tell you, doesn't think of Excel as a modeling tool. I've had so many conversations with them as to why they made this change or that change, and they said that's what the business community wants. And I said, yeah, but you just broke everything that made it a great modeling tool for science. Well, it's not intended, they say, to be a modeling tool for science, but there are ways around it, and we'll show you some of those as we go along. So I'll start off by sharing my screen, and just to start off here. So this is part of a 3-part workshop series. We already had a couple of hours in May to talk about the overview, but today and tomorrow we'll be talking mostly about implementing computational thinking through spreadsheets. Next week, we'll talk about system modeling and system dynamics, but we'll also talk about it using spreadsheets. But there's more advanced and easier to use software than spreadsheets for doing system dynamics. Likewise, the 3rd week would be agent-based modeling. So today I want you to think about spreadsheets as a computational thinking sandbox, making it easy for you to just play around and explore different concepts. So let's talk a little bit about computational thinking. We're going to use the same basic ideas we've used before, which is that we're either talking about computational science education, in which you use already built models, already built tools to teach the content of math and science, or we're doing computational science education, which is actually teaching people how to build the models. Today, it's mostly going to be the concepts of what some people call programming concepts, or computer science 101, or computer science 0 in some schools. But what we're really talking about is using a particular environment and understanding what you need to expect, what you can observe, and if you reflect on it, what you can learn from doing that. So the idea is that we're trying to do things that are dynamic, visual, and interactive. And that dynamic, visual, and interactive approach is something that we're hopefully going to show you can be done in Excel. It's not just for XY graphs for some business report, despite what Microsoft tells you. So we want to compute and recompute, visualize and revisualize. We'll realize that there are different ways of representing things as numbers, as tables, as graphs. There's different paths to solution. And Excel offers you to explore those different paths to solution so that you can get some sense of what's going on. And the more different ways that you can end up with the same answer, the more confidence you should have of doing that. So computing begins to be a thought amplifier. So just to get a little bit of idea about web-based resources and other things that you can use, let's first talk about authentic science as being this three-part process that I just verbalized. What do you expect? What can you observe? And what can you learn from those observations? And one of the problems that we have with some students and even some faculty is they have really misplaced expectations on what a computer or what a spreadsheet in particular can do for them in terms of problem solving and problem solving environments. So we'll sort of try to change some of those expectations today or reinforce them if you've been well taught. And we'll go through those in a very careful way. We're not going to really cover it. The Aaron can tell you where to get the videos from the 2 webinars in May, which really covered this in depth about talking about inquiry-based learning enhanced by computational thinking. But I just want to just briefly go over part of the outline. Let's see if this will come up. Nope. For some reason, it's not coming up today. Anyway, this is a more detailed link. I'll make sure it works when I bring it up. But I want to give you some sense of expectation and what computers can do and what you can expect that they would do. And to do that, I want to just draw out a simple calculation. If I was to give you the calculation 3 + 2 × 6, and you can push the space bar to unmute yourself, what would you expect, what would you hope, what would you expect your students to be able to evaluate this expression as being?
15.
15, okay. So if we went to the Windows-based calculator, and there's actually a web version of the Windows-based calculator. This really is an exact port of the Windows calculator that comes up. And if we were to type 3 + 2 × 6, we get 30. And the reason is that the Windows-based calculator is in what it calls standard mode, which is not NCTM standards. It's not National Science Standards. It's not accreditation standards. It's what you type in the order you type it in. They call that standard. And that's unexpected. A lot of people will pull up their calculator on their computer and just type in the numbers thinking that it's actually emulating their hand calculator that they've been using since school, whether it's Texas Instruments or Hewlett Packard, and it isn't. It's emulating that little cheap calculator that's taped to the back of your checkbook, and it's order of entry, not order of operations. If you were to change it from the standard calculator to the scientific, besides noticing that there are many, many, many more complicated things in science than in the standard calculator, if I type in 3 + 2 × 6, now I get 15. So somehow it's a scientific concept that order of operations is actually observed. And that's something which, again, is not expected for a number of students. Now, if you were to go to Google and type in 3 + 2 × 6, something for some people is unexpected is that Google, as soon as you type in 3 + 2 × 6 and hit enter, not only does it search 25 trillion web pages, but it gives you the answer and a calculator to go with it. It also gives you something else. Can somebody recognize what's on either side of 2 × 6?
Parentheses.
Right, and that's emphasizing this idea of order of operations, that the 2 × 6 was done first, and then the 3 was added to give you the 15. Now, because it's an information calculator, there are some things that, when you're calculating simple things that a spreadsheet won't do. So for instance, you could come over here and type in the Roman numerals 3 plus the Roman numeral for 2 times the Roman numeral for 6. And what do you expect that it's going to give you? It actually gives you the Roman numeral for 15, which is the expected answer if the Romans knew how to do order of operations and if plus and times and things were all the same. The other thing is, if you were thinking that your teacher wanted you to type in the words 3 + 2 × 6, Google recognizes that as an expected calculation and goes through and gives you the answer as a result. But it's more than that. This calculator is also an information calculator. If you wanted to calculate the mass of the Earth, it would give you a number. And if you said divided by the mass of Mars, it will go out and find the values for the mass of the Earth and the mass of the Mars, do the calculation. And so it's not a matter of looking something up and typing it into the spreadsheet. Google itself is doing the calculation. Now, the question you have to ask yourself, of course, when you're using Google is, how do you know if it's right? And those are things that are questionable at best, because a lot of these things are not properly sourced. And then, of course, there are other online calculating environments. There are some that do specific things. There's a website that just does derivatives. There's a website that does integrals. And Wolfram Alpha has put their front end as a web-based interface to Mathematica. And of course, you're getting the ability of typing in answers and doing things. You can also do derivative of x squared. So you don't necessarily have to be a programmer to do these things. You can pretty much come out and figure out where these things are going. So as we're talking about using a spreadsheet as an introductory computing environment where students do not have to overcome a fear of programming or things they might have heard. They don't have to overcome a inability to type well. They don't need to overcome a fear of syntax. They may have heard that programming was only for smart people. But over the last couple of years, this CS0 or Introduction to Computational Science course has basically identified programming concepts which are important for students to get some idea what they're about and how they're about. So here's a list that I made, and we're going to cover these over the next 2 days, just using Excel. Some of these can also be done in Sheets or Apple Numbers or some other spreadsheet environments that you might have. But obviously the use of variable names, how to do assignments with operators, an important difference between numerical and algebraic representation, and what is the impact of formatting or round off or truncation? What about the use of randomness and random number generation, or more properly called pseudo-random number generation? How do you think through the process of iteration or recursion? Different things of conditions and branching, and we'll look at both simple and nested if statements through if then else, or if then else, if then else, if then else. We'll have a little bit of exposure to Boolean operators. We'll expose ourselves to color as a numeral or an introduction to scientific visualization. And mostly left for tomorrow, we'll do some exercises in parallel thinking, taking advantage of the peculiar way in which Excel actually calculates a spreadsheet. We'll show you some examples of system models and explore some agent-based models. Really, again, emphasizing the idea of being dynamic, visual, and interactive. So one of the things I want to anticipate is that because every 2 years, Microsoft has changed features or where features are located or how features are accessed or what they're called, I'm going to use basically Excel 14, I guess it's called. And what we'll try to do is, if you're following along and are not getting the same results or getting caught up in things, put a note in the chat window. Aaron will try to alert me to it. We'll also try to spend some time at the end of the day going over individual cases of things that are going on there. Some of the changes are more substantial and they would actually make spreadsheets that you might have used for years. You upgrade Excel, you upgrade your copy of Excel and the spreadsheets start giving you errors. Some of them, they're just cosmetic and some they're just a pain. You just have to put up with it if you're going to get it. But we'll try to go through some very simple examples and show you some things. And again, part of today's goal is to make sure that we can change your expectations to both what Excel can do, what spreadsheets in general can do, some of the differences between the two, and how some of them are actually not the same, and some spreadsheet instantiations will have more value than others. So now let's take a little bit of time just to get the idea of who's able to do what. We're going to do a very simple model that will look at variable names, assignments and operators, and controls, and especially, if necessary, teaching you how to become a developer. So what I want to do is, if you right-click and save as, you can put this Excel file anywhere you want. You may be able to just click on it and open it. I don't know how your computer is set up to work. I'm going to save this in my downloads folder. And so if you open it up, my first question would be, are you able to open up Excel? And do you get a simple spreadsheet with 5 tabs at the bottom? So why don't we take a moment to just find out who's able to and who's intending to track along with me. Speak up or raise your hand if you're not able to, but you want to be able to open this file.
We don't have this link.
You don't have what?
We don't have the link to this document.
The document is part of the Google Doc that I linked earlier. There's a link to the presentation.
Okay, so let me go back and start from the beginning of my presentation. Okay, so this is the presentation that has the link to the Excel document and all the other things that I'll be using today and tomorrow.
So is there any good way to download that presentation?
There's not an easy way to download the whole presentation. You can access it on the web.
Yeah, for accessibility reasons, there probably should be. But when you get to the Excel file, is there anything on it other than the tabs? Or is it
One of the
just-
tabs has a bunch of typing that would take a long time.
Okay. But the rest of them are supposed to be blank?
The rest are supposed to be blank. The reason I did it this way was to give us an easy way to tell whether if you wanted to follow along, you would be able to. Okay. So I'm going to be sharing my Excel sheet. And so the first question I would ask in terms of expectations, based on what we've already done, is does Excel follow the normal expected, or do spreadsheets follow the normal order of operations? What do you expect? If I was to type in 3 + 2 × 6, you get 15.
Yes.
Where you get in trouble is if you go beyond some of the more subtle ones. If you type in -4 squared, what would you expect that to be? Anyone?
16.
It's gonna end up as -16 because it's gonna have that negative outside.
Well, apparently spreadsheets have decided that the negative goes with the number. They call it a unary operation, not a binary operation. And so even if you were to go to another environment, let me do 2 for examples. If I was to go to Google and type in -4 squared, it would tell me it's -16. If I type in the words -4 squared, I get -16. If I go to Wolfram Alpha and type in -4 squared, you get -16. But if you were to do that in Excel or Google Sheets, you would get 16 because somebody convinced the spreadsheet programmers that the minus in front of the number goes with the number. And it doesn't do the exponentiation first and then put the minus out in front. So you've got to be a little careful. Not all of the order of operations things matter. We'll get to some other things. Now, the other unexpected is the difference between formatting, truncation, and round off, and depending upon what we're doing, and we'll get to that a little bit later. But for now, I want to do a really simple model that looks at how variables can be used to make the calculations in a spreadsheet more reasonable. Now, I'll display my prejudice, which I hope doesn't count against inclusion. But suppose you had a world in which cats still existed, dogs and pets. And I had 3 cats, 4 dogs, and assuming the pets were the sum of the cats and the dogs, how many pets would you expect this little spreadsheet to calculate for you?
7.
7. Now, I don't want you to do this, but I'm going to show you several mistakes that my students have made that completely fooled me when I walked around the room and looked at their screens. I would have students that would type in a 7 here, and doesn't that look correct? That a 3 and a 4 give you 7, but you can't easily tell that they typed in the 7. When I would detect that error, I would say, no, 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 you add the 3 and the 4, let the computer give you 7. And they would type in equals 3 plus 4. And it would, again, look like 7, and it would look like they're getting the right answer the right way. But you can't really tell because that's not how you want spreadsheets to work. The way you'd prefer them to work is adding up what is in the square representing the number of cats and adding up the cell which is representing the number of dogs. And that way, the computer is getting those. So the cell is not the one that has the word cats in it, it's the one that has the number of cats. So conceptually, can somebody unmute and tell me how do you calculate the number of pets? What do you add up?
A2 plus B2.
Well, but those are the cell names. What's the concept? The number of,
3 cats plus 4 dogs.
right. But again, if this was over here and you said it's equal to A2 plus B2, but if I somehow moved these, it would change this to being A3 plus B3. So somehow it's linking. Once you make the link, it doesn't necessarily stick. You've got to be careful. Now, Excel for many years has had the ability of coming to this cell, and even though you would say correctly that it was called A2 because it's in column A, row 2, I can go up here in the corner, upper left corner, to the name box and type in the word cats. And now this cell has the name A2 and the name cats. Likewise, I could come here, and another way to do it is to go to the formulas and define the name. And it says, oh, I'll bet you want to call that dogs. And if you did, it would now be called dogs. So if I came over here and typed in cats plus dogs, now the concept cats plus dogs is the same as the equation cats plus dogs. It's no longer A2 plus B2 or A3 plus B3 or A57 plus G96. And so the idea that you can have variables for individual cells, or you can have variables for entire ranges of cells. Now, if I wanted to do an exploration of how does the number of pets change as I change the number of cats or change the number of dogs, you could come over here and change this to a 2, change this to a 4, change this to a 1. And every time you click, change the number. But it would be nice if we could do this in a much more dynamic way to see the pattern of changes that's going on. So now my question is, this is the next experiment for the group. if you look at your menu at the top here, home insert, is one of your tabs developer?
Yes, but I had to figure out how to turn it on the other day.
Okay, well, that means that there may be other people here that don't have it. So
I
let's,
don't have it.
okay. So let me tell you the story. In the old days, which means about 6 years ago, everybody was able to do dynamical things interactively. And under the pretense of cleaning up the ribbon, Microsoft got rid of some things. In fact, they only got rid of one thing, and that was the ability of adding slider bars, dials, controls, pop-up menus, radio buttons. And the way you would get to that is different for Macs and PCs. So I'm going to explain it for the Mac people first. Under Excel, if you go to Preferences, at least my version now has something that says Ribbon and Toolbar. And under the main tabs, there is one link, which in my case, prior to adding it, was unchecked, and that was Developer. If you're on a PC, you want to go to Options, Customize Ribbon. And again, under the main tab, you should see, if you didn't have Developer, you should be able to check a box that will make you a developer. Is there anybody that was not able to find that or to become a developer?
There is no options in my menu on PC.
What kind of machine are you on?
Windows 10, it's the Microsoft 365.
Right, but do you have, instead of, you don't have options?
No.
You need to click on File,
Oh, file
and then
first.
Options is going to be the very last option
Okay.
at the bottom on the left-hand side.
Okay, so that's what I missed. You didn't say first.
Yeah, I don't have a PC in front of me to describe what you would be seeing. So I'm very glad that there are other people on there that can chime in. Thank you very much. Are you able to see that option now?
Yes, but I'm not sure what to do next.
Okay, so you should be looking for something that says Customize Ribbon under the options.
I can't find it yet. Okay.
Did you click on Options?
Yeah, I see it. Okay. Yes, got it.
And then you see Developer.
Yes.
Okay. So my question is everybody who wants to be a developer, are you now a developer? Now, the reason what they hid by taking away the developer tab are these interactive tools that make the thing more dynamic. So let me show you what happens with a scroll bar. If you click on a scroll bar and move your mouse onto your spreadsheet, it becomes a microscopic cursor cross. And if you click and drag a rectangle, you will see a less than, greater than, and something in the middle. If you right click on that, you should get something called Format Control. And let's say I want my current value of cats to be 3. I want a minimum of 0 and a maximum of 10. Are you seeing my pop-up menu, by the way?
Yes.
Okay. The incremental change, I'll make 1. And so you can see that it does something. I'll make the page change 3. And I'm going to link it to the cell that I called cats. Now let me show you.
Bob, there's a message in the chat that on the developer menu on 365, there is no scroll bar.
Okay. Let me let me see what we can do here. Do I have the ability of letting people share their screen?
I'm not sure. I can. It looks
It's
like
under the insert button.
So you may have something that says insert ActiveX or insert format controls. You want to insert the format controls. And one of those format controls is a scroll bar. Great, thanks for the help. You can tell that this is not like teaching in a lab where you can walk around and every kid's got a different computer, but you can still pretty quickly figure out what things are going on. But I appreciate your patience in helping us get going. Now, if you look at what I did with my format, where I gave it a value, a minimum, a max, an increment, and a page, and I said it's controlling cats. Now, when I hold if I click on the end, I can make the scroll bar move up, or I can make the scroll bar move down. And I don't have to keep clicking, typing, and I can see that as you increase the number of cats, the number of pets also increases. Now, every time you click the arrow, the incremental change, the cats change one at a time. By how many cats does it change if I click in the gray area?
Three.
And that's what I called the page change. Do you remember when I did the format control, I made the page change 3. So you can either grab the knob and move it. You can click on the up arrow or down arrow, or you can click in the gray space. So you have a fine control, which is the incremental change, and you have the page change, which is a more coarse control typically. So you could have a model set up that depended on the resistance or the infection rate or the initial population, and then you can control that model with different sliders or what they call scroll bars to get some idea of how you can control your numerical model rather than type a number, hit the return, try to find what changed. Now, the graphic interface is not as good as it used to be. In the old days, namely 2 years ago, if you actually grabbed the knob in the middle and moved it, the knob would move. Now it only moves when you let go. There's 2 parts of Microsoft. One is the GUI part and the other is the numerical part. And they're each blaming the other for why this change happened, why it doesn't work very well anymore. But that's one of the things that you can figure out is this idea of a dynamic model, not just a static model where you do it once. And one of the things that makes this easier is the fact that we gave names to the cells that had the values in it. It's not automatic, but it's almost where you can figure out how to give these different things names. Now, what I'm going to do here is move over a few cells. And we'll show you the difference between naming a cell with a variable name and naming a column or a range of values with a variable name. So suppose I wanted to make an XY plot. And what I'm going to do is I'm going to call F. I'm going to click on column F, and in the name box, I'm going to call that X. So besides being column F, everything in that column will represent a variable that I'm calling X. And everything in G, I'm going to call Y. Now I also need, for this experiment, I'm going to make a linear function with an M. I'll call that 2, and a B. I'll call that 1. Now what I can do here is by clicking on the value of M, I can go to the name box and call it M. Clicking on the value of B, I can go to the name box and call it B. And then I'm going to start at 10. I'm sorry, start at -5, and then minus 4.9. And if I highlight those two, one of the powers of Excel is called pattern recognition. And by looking at 5 and 5.2, it's guessing the next number is going to be automatically filled in there. So I can build now, one of the things we're going to sort of anticipate here is if you look down on my screen, what's the next number after -0.1? What should be the next number? If I'm going from -5 to 5 in increments of 0.1.
0.
And actually, I don't get anything close to, well, it's close to 0. It's 10 to the -14. But this is the effect of round off, and we'll talk about that a little later. Just to make it clear, I'm going to make it a 0. Now, if you were to talk about the sound of a linear function, somebody said, give me the equation of a line, what would it sound like? Y equals what?
MX plus B.
Right. Now, the difference here is we can say Y equals M times, and on the newer versions of Excel, you need to put an @ sign because it tells it to go to the horizontal row and pick up the value that's in the column that's labeled X.
Can you go back through how you labeled that entire column?
I touched the name of the column that Excel gives it, which is F in my case. And then I went to the name box, which is in the upper left corner, and typed the name I want to give that column. I gave it the name X. Now, I'm not saying it's the greatest thing since sliced cheese, but only about a year ago, you didn't need this @ sign, and you could actually type in M times X plus B. Now, because of other things they wanted to do with a matrix calculation, if you want the value of your row in a column, you need the @ sign. And if I take that and double click down from the lower corner, every cell is MX plus B. Now, I want to show you what would normally be done. And that is, that this would be $J, $1 times F2 plus $J, $2. So the question is, which one of these representations would remind your students more that you're representing a line? The one that has mx plus b in it, or the one that has $J, $1, F2, $J, $2? Doesn't this one look more like a line? And a lot of our students find it's more reasonable. Now, again, it's identical. You'll get the same values all the way down for the value of y computed the old way. But again, the difference is it doesn't look like the representation algebraically of a line as much as the way we did it where we're using variable names to represent an individual cell. You don't need the at, or at and the name of the range if you're doing that. Now, the names survive the sheet. So once you use a name in a sheet, you can't use it in the same workbook for something else. Like, for instance, if I came over here and created a new sheet. Let's see if it'll let me do that. Or I'll just pick some other sheet here.
And Bob, there's a comment in the chat.
Okay,
Getting a function isn't valid message when typing the equals m times at x plus b.
Yeah, I
Good.
got the same error message as this
good.
one.
So let me back up and check something. Depending on your version of Excel, you don't need the at sign. So get rid of the at sign if you have an older version of Excel. If you've properly defined, okay, now the problem is I work at a college that automatically updates my version of Excel to the newest version, and so I can't go back and deprecate to an earlier version. So thank you for telling me. But that's why I said, if you had an older version of Excel, you wouldn't need to do this. The new version of Excel, the at sign is required now for the newest version of Excel. I preferred it without the at sign because mx plus b looks more like a line than m times at x plus b. But just so you know that that's notation, that means go to the horizontal line and pick the value in the column. Did that fix it for everybody that was getting an invalid function?
Yes.
Okay. So again, this is a little bit the difference between teaching in person in a lab. And we can go through and do a bunch of norming exercises and figure out which versions of Excel people have. It's a little bit harder online, but I appreciate, again, your patience and telling us when it doesn't look like it's working. My experience is, it is true that it's almost always the fault of the software and it's not student error. Sometimes it's student error. But many times, because Excel every 2 years keeps rolling out a new version with new features, like hiding the developer tab, moving it from layout to customized ribbon, the use of this @ sign. So if you would please try to remember, if you, for this simple one-line exercise, didn't need the @ sign, you're not going to need it going forward either. Anyway, I've picked any one of these others, like does it add up? And if I came over here and said, oh, I know what I'm doing wrong. If I came over here and said equals cats or equals dogs, then it will go back to the other sheet and pick up that value and pull it into this sheet. So it can really clean up your worksheets when you're using more than one sheet. And you don't necessarily have to have big, long sheet names that carry it along. The variable name knows what sheet it came from. Okay. Any questions on the simple model or what we did? And again, we could come over here and put in a scroll bar, go to Format Control, Control column M, make the current value 0, minimum value 0, maximum value 10. And then depending upon how that works, I can, by clicking on this, I can get it to go all the way up or all the way down.
I'm sorry, Bob. Can I ask you a quick question?
Yes,
For some reason, I'm on the Mac and I'm a latest version of the Excel, and I can't get to this range bar in the developer. It gives me some weird stuff. When can you show one more time? Are you right clicking on the any cell to get to that range bar?
do you actually see this arrows
Oh, I
on?
do. That's the reason. I get everything else, but not that bar.
Okay, you don't have the latest version on the Mac. What you're gonna have is just a sort of faint faded horizontal bar that maybe has a knob in the middle, but doesn't have the arrows at the end.
Okay. Can you
That-
show one more time how you actually get this GUI on the screen? Get that.
So let me cut this one. So under the developer on a Mac, they give you a whole set of pictures of the things. One is called a scroll bar.
Mhm. Oh, okay.
And you click on that, and when you move your cursor to the screen, on my screen, do you see that microscopic little X?
Yep.
You're supposed to be able to click and drag, and then you'll get something on your screen. But every year they change what this arrow looks
Oh,
like.
okay. Yeah, finally came up. It was all the way at the bottom, so I had to then drag it all the way up. So it wasn't actually that. That was the reason I couldn't see it in front of me. Thanks so much. I appreciate it. Now I have it.
Right, then you get the format control. And you could say current value 2, 0 to 10. I'm going to control the slope. Then you click away to get rid of the handles. And then when you're moving, Okay. Now we're going to do one short. Anyway, just to give you the ideas, if you were to do this, you can get some dynamic controls. And again, part of my assertion is that having it look like the equation that it represents, page 42, equation number 17, is a lot closer if you use variable names than if you don't. Otherwise, you have to use the old notation with dollar signs for meaning scalars or constants and variables that move and change around. Are there any other questions on this simple thing that we've done to start out?
There is a question in the chat. It says, I'm confused why we need that bar. Can you please explain once again?
Okay, so you don't need the bar, but it makes it easier. Suppose I wanted to say, how does this thing change if I change the intercept to 4 or change it to 6? The changes on the spreadsheet are so instantaneous that you don't actually see the effect of, as the slope gets bigger, what happens to the function. If I put a graph on here, it might make it a little easier. If I insert a scatter plot. Let me highlight these two. I'm going to insert a scatter plot. Now I should set the axes more carefully, but the idea is that you can get a more dynamic vision of how the graph changes. And on the axis, we'll make it minus 30 to 30. And display the units. So can you see that as I increase the slope, it gets more steep? And as I decrease the slope, it gets less steep? So the idea of having the scroll bar gives you a more dynamic control over what's happening. Now, the last thing we do before we take a break is I want to explain that the limitation of the way Microsoft does this is that the scroll bar has to be 0 or a positive integer. But what if you wanted the value of this to go between -5 and 5? Well, then you have to come up with a function that is based on this integer that gives you the values that you're looking for. And so you would have to create something that would take this slider bar. Let me show you what I mean. Under the format control, instead of controlling the slope directly, I'm going to control the cell K1. And I'm going to give myself 20 different values. Now, what you should see is that this cell now goes all the way up to 20 and all the way down to 0. And what we can do is we could say that this is equal to, again, I want to make this slope to be able to go from -5 to 5. So I could say, I could add this cell divided by 20. And then multiply that by the distance from -5 to 5. So now if the slider bar is already at the lowest edge, it'll start at -5. And now if it goes to the upper edge, it goes all the way up to 5. So you, the thinking human being, can use a scroll bar to control an integer and then calculate a function of that integer. So you can think of it as the left endpoint plus a fraction of the distance from the left to the right. So the range is 10, -5 to 5. And when you're at 0, you'll add none of this fraction. And when you're at 20, you'll add all of it. So you, the thinking human being, can actually make a control that is not only -5 to 5, but can go in fractional increments. But can you see how you can visually link this to your students so that you can see that as you move the slider bar, you can see the slope and the line change, and you can make that visual connection for them. And that's hard to do if you're just typing a number and hitting the return, typing a number and hitting the return. Does that make sense? Okay. So again, one of the advantages of doing this is it makes Excel dynamic and visual and interactive. But you're limited by Excel that the slider bar by itself only does positive integers. But you can change that to go from any point to any point in any increment by just mapping it. When I was a kid, we used to learn table interpolation, and we liked it. And now you have this coming back and being of good value for things here. Okay, one of the things I forgot to mention at the beginning was that we're going to take a short break every hour to catch up on any questions and to give you actually a break. Why don't we start back up at 2:20? It's now Eastern time, 2:12, and we'll come back at 2:20. If anybody has questions, you can either unmute or put something in the chat window, and I'll try to catch up anybody that isn't where we are right now. Okay, are we back?
Yes.
Okay, so what I'm going to share, just to give you an outline of what we'll do for the next few minutes. Is we're going to talk about algebra, arithmetic, and numerics. Especially, these are concepts in programming, in teaching kids on how to build code, which are very important. They need to know what's exact and what's approximate. When in English do we use the word is, and when do we say is almost? And there's a difference between formatting, rounding, and truncation. In other words, what does the answer look like, and is that what the answer really is? How faithful is what's showing on the screen to what's being stored in memory? We'll also look at the loss or loosening of simple laws. By laws, I'm referring to the commutative law, the associative law, the distributive law, the existence of an inverse, the existence of a zero. Zero being defined as a number when added to a number gives you the same number. And the fact that not all spreadsheets behave the same. And we want to sort of keep that in mind, because if you're teaching an introductory class, these are issues that come up in different cases. So to follow along or to watch me do this, I'm on the tab at the bottom that says Fun with Almost Pi. And I want to start off by asking you a question, again, pushing the space bar down and just telling me the answer is probably easier than, or you can put it in chat and Aaron will let me know that it's there. But if I had the expression 3/6 minus 3/6, what would you think that if I evaluate that expression, I'm going to put an equal sign in front of it now. If I hit the return, what would you expect to get as the answer?
0.
0. And if you hit the return, do you get 0?
Sort of.
Sort of. So let's test this. I'm going to ask the question, if what's in that cell really is 0, I want you to write 0. Otherwise, I want you to write not 0. So when I hit enter, what do you think it's going to say? 0 or not 0?
Not 0.
It says 0. Now, if I was to go to Google Sheets, and do the same calculation and do the same test, if the thing to my left really is 0, I want you to type 0. Otherwise, I want you to type not 0. Oops, I didn't type that correctly. I put a quote, need a quote there. So on Google Sheets, evaluating this tells me it's not 0. But if I did it in Excel, it would tell me that it's 0.
Numbers also comes back as not 0.
Pardon?
Numbers, which is the built-in spreadsheet to Max, also comes back as non-0.
Right. Now, if you're doing numbers and if you go up in between 2 columns and you make it as wide as possible, you'll see it'll automatically format it and give you like 19 zeros and a 1 in numbers. Now, let me go back to Excel and talk about what's happening in Excel. And the answer is Microsoft doesn't think you can handle the truth. Microsoft thinks that you expect to get 0, and if you didn't get 0, you would think there's a problem. Now, if I come back here and put this entire expression in parentheses, I'm not doing a distributive or associative law. I'm just taking the expression and putting it in parentheses. That's like Microsoft telling itself, don't lie. Tell me what's really there. And can you see that you really get not 0? And if you went back and did this in Google Sheets, the parentheses don't do anything, but what you have to do is format the number. And if you format the number to give you a bunch of zeros and tell you what's really there, you can see that you're getting the same number or the same numeral as we got in Excel. Now, the problem is even worse than that. So let me do this in English. In English, 3/6 is a half, which is exact. It's a power of 2. But if I was to ask the question, how does Excel represent 1/6? Is Excel rounding the number? Is it truncating the number or doing something else? What do you think? Is this number rounded, or truncated when you get to the end of the number of bits that Excel is using?
Is it rounded?
It looks like it's rounded. Now, if it's rounded up, that means that this number 1/6 is actually more than the exact value of 1/6. Do you agree? So if I came over here in English and said, what do I get if I have exactly 1/2 minus more than a sixth, minus more than a sixth, minus more than a sixth? What kind of number would you expect that I would have? Positive or negative?
Negative.
And yet it's positive, which means that this representation of 1/6 is misleading. The reason it's rounding is because when Microsoft surveyed its customers, the customer said they would prefer it rounded when they saw it, even though the actual number in memory is truncated. Microsoft expects you to see this number as a rounded number because that's what they learned in elementary school and middle school and high school. But it's clearly positive and it's clearly not rounded. So this is a formatting issue. In the same way in Google Sheets, you don't see the answer unless it's actually formatted. Okay, so Google Sheets and numbers, you can tell that it's truncated, but not necessarily as easily. If you did this in Python, Python would show you the last digit as being a 6. Now, I want to show you this is not just an Excel problem, it's a numerical problem, but Excel makes it worse by hiding it in some cases. What Excel does is if the number is so small that you would think it's 0, it actually lies and replaces it with 0. Do you remember that if statement I used? If it's a 0, say 0. And when we didn't have the parentheses, it said it was 0. Once we put the parentheses there, it was not 0. Now, if we came over here and went back to our friend Wolfram Alpha, and we said 3/6 minus 1/6 minus 1/6 minus 1/6. I haven't hit the return yet. And do you see that by not hitting the return, it says that it's 0 because it's doing it symbolically? If I come up here and put a period, a decimal point at the end, excuse me, it automatically computes it numerically, not symbolically, and the answer is not 0. Okay. So this is a big concept in programming is what do you need to know about numerical computing? What do you need to know about round off truncation and formatting? How do you know if it's right? And testing the number is important. Now, let's do a small numerical experiment. I hope you'll agree this is 3/6 minus 3/6. Do you agree that this is also 3/6 minus 3/6? But if you do that, you get a different not 0 than if you divided this 2/6 into 2 individual sixths. And then if you use the commutative law, it goes back and gives you the other answer. So it turns out commutative, associative, and distributive properties are not maintained when the calculations are done numerically. If they're done algebraically, they're there, but numerically, because of round-off truncation and formatting, you don't necessarily retain the same answers depending upon switching two numbers or associating them with or without parentheses. Now, to make it, to give you a little bit of exercise in numerical computing, Excel and most math libraries have a stored constant that's called pi. Before that, in Fortran, you could always calculate pi as 2 times the angle whose sine is 1. That's pi over 2. Or you could have 2 times the angle whose cosine is 0. That's also pi over 2. Now, if you grew up in a family with 6 kids and not enough money to afford a calculator, at Notre Dame back in the old days when they let us use calculators for the first time, I got a Texas Instruments instead of a Hewlett Packard. And on the back of the Texas Instruments on silver tape, it said, oh, you don't need a pi key. Just use 355 divided by 113. And you've got to admit, that's a pretty good approximation for pi. Now, what I've done for this little exercise is I've divided 355 113ths into 101 113ths. So I'm calling that the large fraction. And 3 times the large fraction plus the small fraction gives you 355. So the first thing, again, use the space bar to chime in or type something in chat. Would you agree that these 7 representations are all algebraically the same? If I took 355 113ths and subtracted off 355 113ths, it doesn't matter algebraically which order you do them in. But what's kind of unexpected is that if I do it and write that algebraically 7 different ways, oops, I hit my screen. So 7 different algebraic expressions give 6 different answers. And one of those answers is actually 3 times larger than another one of those answers. So again, the lesson here is that you can use Excel to explain a very important, it's almost a theorem. Expressions that are algebraically equivalent might not be numerically equivalent. And that when you're coming up with 2 students could do the calculation 2 different ways and end up with algebraically the same answer, but numerically their codes could be different. And this is almost always when you're dealing with the differences of numbers that are close together, where you have a small number as the difference that has a very large relative error in that kind of number. And you can use Excel to demonstrate what that problem is that's going in there. Now, going back to Excel, I want to show you what happened when we tried to build a straight line. I'm just going to go over a couple more rows, a couple more columns. And I'm going to put in 10 and 9.8. And if you remember what I asserted earlier, Excel can recognize the difference between those 2 cells and then apply that difference all the way down. The problem is, well, let me ask you what you see as a problem. What is the difference between 10 and 9.8?
0.2.
It's actually almost 0.2, because 0.2 is not exact on a binary computer. Only powers of 2 are. So if you want to watch for yourself, me, or do it yourself, start at the 10 and look at the number there, and also look at the number up in the formula bar. If you start going down the numbers, how far down do you have to go before there's obvious that there's a difference? Can you see it's actually not that far? It's only like 7 subtractions. If you get down to 8.4, that the number, even though Microsoft is changing the answer to be exact, by the time it gets to 8.4, the error is so big that it can't hide it anymore. Now, one way to get around that partially is that instead of subtracting 0.2, subtracting 0.2, or subtracting almost 0.2, subtracting almost 0.2, is to take the number with the smallest error and using somewhere on your menu bar on the homepage, there should be a fill command. And if you fill the series, minus 0.2, and we'll stop it at minus 10. And we'll do it in columns, make it linear. So it certainly looks like it's going to be much better. So this is not doing repeated subtraction. It's actually multiplying the spacing times the step size to get that number. And if you subtract those two, you can see that there's a big difference in the representation. And in some cases, it's similar, but the answers are actually much bigger than you would think. So the basic idea of that exercise, first of all, is to do the use of the variable names again, and the assignments, and then highlighting the ability of Excel to distinguish numbers that if the error is small enough, it will make the answer 0. Even if it really isn't numerically, it will try to hide some of that. I've been told it's because the business community can't handle the truth. You know, it's like A Few Good Men. You know, the movie where it says, you know, I demand the truth, you can't handle the truth. Well, a lot of people can't handle round off and truncation or a change in formatting. So we'll kind of go through that depending on how things work. Any questions, comments, or concerns about that? Okay, so what we're going to do now, let me go back to my
And Bob, can I just say real quick, I've put a link to Google slide version of this HTML presentation in the Google Doc. So if you want to download these as slides, that is
Well,
available.
I'm glad you know how to do that. What did you just turn it into PDF or?
There's a lot of copy and paste, actually.
Sorry. I'll try to give you more heads up when I do this. Okay, so I think we've explored what's exact and what's approximate. What's exact on binary computers are powers of 2 and the integers. There's formatting and rounding. There's the loss or loosening of simple laws. The order of operation can affect the answer, and not all spreadsheets behave the same way. So now what I'd like to do is to spend a little bit of time talking about randomness in simulations. We're going to use both variable names and names for ranges. So again, if you're on a newer computer like the one I have, I'm not a newer computer, a newer version of Excel, you may or may not need the @ sign. So you know better than I do what you need. We'll look at different uses of conditions, both nesting and branching if statements. We'll look at how you can teach students about polling, which is an important algorithm in introductory computer science, what I'll call the brute force method versus using a math library. We'll do some things with Boolean operators and talk about how different models could have analogous results depending on how the randomness in the simulation works. And we'll talk a little bit about spectral tests. When we do the spectral tests, if you keep in mind on this slide of the talk is a link to a simple histogram tool that we'll use because making a histogram in Excel is idiocy, personal opinion. So using the same spreadsheet for now, if you click on the link that says coins, the tab at the bottom that says coins, we'll start with a simple introduction to a pseudo random number generation in Excel. Almost every,
sorry, can you switch to Excel? Sure. We can only see the browser right now.
aha. So I stopped the old share. I thought if I clicked on it, it would work. Okay, you're right. Thank you for telling me so soon. Okay, can you see where I am here?
Yep.
All right. So every reasonable computing environment has typically a math library call that will generate a pseudo random number, which is a mathematical calculation that gives you a hard to predict number between 0 and 1, sometimes inclusive, usually non-inclusive. And if you were to do that, depending on your machine, you should get a different value than the one I got here. One of the things that we learned when I was teaching this class using a shared Google Sheet was that even though on a shared Google Sheet that everybody was using, people didn't get the same random numbers, that the numbers were not preserved across sharing. So this is what I typically teach as the first real programming strategy. So if I was to ask you, every time you evaluated this, you would get a different random number. On a Mac, you should be able to hold down Command equals. On a PC, it's F9. Can you all verify that you're able to just hold down Command equals on a Mac? Or I don't know what it is in sheets or numbers to do the calculate the spreadsheet again.
I think in Sheets, as long as you edit a cell, so you can put your cursor in a blank cell and just hit delete, and that will recompute.
Okay, and that's Google Sheets?
Right, that's Google Sheets, yeah.
Okay. So the question I would ask you is, what fraction of the numbers between 0 and 1 are greater than a half? And what fractions of the numbers are less than a half? So I could come up here and create a coin and say, if the random number was less than a half, I'm a heads. Otherwise, I'm a tails. So in the program, in Excel, in most spreadsheets, the if statement is really an if, comma, then, comma, else. And either the then or the else could be another if. So in this case, I got a heads, another heads, a tails, a tails, a tails, heads. Now, it's hard for you to tell that that's happening. So what I'll do is I'll just copy this down. 10 rows. And you should be able to see that every time I hit Command equals or F9 on a PC, you get 10 values for heads, some of which are heads and some of which are tails. Now I'm going to start this exercise very slowly on polling, because I could go down and with only 10, I could almost inspect by my eye that there are 4 heads, which means there must be 6 tails, or that there are 5 heads and 5 tails, or there's 7 heads and 3 tails. Or I could actually go down and count them all. But the idea is, what reason do you have to believe that the pseudo random number generator is actually good enough? So one thing you could do is you could say, I'm going to call this column coins, or just coin, singular. And then I'm going to say equals if, and again, this is where if you don't need the @ sign, don't use it. But I'm saying if @coin equals heads, I'm a 1, otherwise I'm a 0. And I'll copy that down. And so what you can see is that every place I have a heads, I have a 1, and every place I have a tails, I have a 0. And that holds true all the way down. Now, for 10, it doesn't really make a whole lot of difference. And then I could come over here and I could say, let me sum everything in column B. And this is shorthand for notation for everything in column B. And if you went down and counted 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So this is what I would call the brute force way. You assign the value 1 if it's a heads, 0 if it's tails, add up all the ones, and that tells me how many heads you have. And for 10 values, that's not such a big deal. But if I go down and did it for a bunch of values, then the question is, that would be a hard thing for you to do by hand, but the machine doesn't care very much. Now, the question is, how do you tell how many coin flips you have, of which 441 of them are heads? Well, you can count A in Excel. Some machines have, some spreadsheets have a different version. And again, what I want to do is count everything. Let's count A this time. So by counting how many cells in column A actually have something in them, then there's 911 rows that have something in them, of which some fraction of them are heads. And if I took the fraction of heads and divided it by the total number, what would you expect to get? About half of them would be heads and about half of them are tails? So what we're able to do, excuse me, is to have this experiment where the computer can do it hundreds or thousands of times. We could do this by brute force, by having this extra column. But it also turns out that there's another counting command in the math library where we wouldn't have to teach kids how to raise their hand if they're heads or keep their hand down if there's tails. Although being able to do that in a programming class is a good algorithm. So if we just said, if we want to count the number of coins, so whatever's in column A, and what we're going to look for is heads. If this is the right use of this function, then we should get the same number that we got when we did the polling, than when we simply looked at how many things in column A are actually heads. So there's a library function that checks a particular range and looks for a particular string, or we could look for the string ourselves by asking, is the thing there heads? Then it's a 1, otherwise it's 0. And the sum of all the ones gives us the number of heads. Any questions? Are there any substantial differences with other spreadsheets on how we did this? Did anyone try it in sheets or numbers?
I tried it in numbers. The only thing I couldn't figure out is how to auto regenerate it. Like
Okay.
where you can make the numbers change.
Yeah, I did not spend a lot of time on it, but in the short time I spent, I didn't see how to do it. I think
Anytime you drag it down, it regenerates all of them. But other than that, I haven't figured it out.
if you double click on a cell and hit enter, does it?
It gives you back the same number.
So the question is, did I use a function in D1? And the answer is yes. The function is count A, which tells you how many cells have something in it other than a blank cell. Let me show you. If I took this cell and deleted it, then count A goes down by 1. If I got rid of this, then count A goes down by 2. Okay, that answered that question. Now, there's lots of things that, you could use a computer to simulate a coin flip, but a coin flip simulates something in nature. So I'm just going to leave everything in columns A through E and using the same spreadsheet so that later I can come back and review it. I'm going to call column G mom. And I'm going to put column H, I'll call dad. And this is actually doing a genetics. And if I said, if a random number is less than a half, let's say I have the dominant gene, otherwise I have the recessive. And I'll do that for both parents. And I'll do that for a bunch of pairings of a dominant and recessive gene. Now I'm going to call this column child. And I'm going to introduce a Boolean function, which is and. So can somebody in a few English words give me the condition by which the child will inherit the recessive gene?
It's both the parent and the both parents must have the recessive gene.
So could I express that if and mom, or if you don't need the and, don't use it, is recessive, comma, and dad equals recessive, comma, then the person will be recessive. Otherwise, if that's not true, they would be dominant. So here's the story. If the mom is recessive and the dad is recessive, then the child is recessive. Otherwise, the child is dominant.
Kind of simplified view of genetics, but yeah.
So that should mean that if it's recessive dominant, should be dominant, dominant recessive should be dominant, but recessive recessive should be recessive. Does anybody want to remind me what the name of the square is that begins with the letter P?
It's a Punnett square. Bob, just a quick question. As far as the columns G and H, can you hear me?
What was that?
Hello? It's a Punnett square. Can you hear me?
Yeah,
can-
we can hear you.
Okay, great. Quick question, Bob. How did you come up with the data in columns G and H?
Okay, so first of all, I gave this the name mom. So the first one is this relationship. If I just gave it the possibility just to generate something that half of the time it's going to be dominant and half the time it's going to be recessive.
And you just drag down the little square to generate the data in the column.
Yes.
Okay, cool.
So
Got it.
if I went down here,
Yeah, it
and-
would be 100 and something, whatever.
you
N
know,
plus one. You could go to infinite as far as yeah, got it. Mhm.
right, I could do it more. And then I could come back up here and double click and it'll go down as far as the other one went down,
Right. The same guy.
right? And now I could do the same thing. I could say count a mom, and that'll tell me how many rows I'm using. And then I could say count if child equals recessive. That should be a comma, not equals. So count if, you give the range that you're checking and what you want to check it against. And then if I wanted to calculate that fraction, what would you expect that fraction would look like? That's right. That's 20, it sounded like 25% to me. Those are smart dogs. So the idea is that a coin flip and the assignment of a random dominant and recessive gene in a population could be very similar. Now, it doesn't have to be 0.5. We may find out that certain genes are 0.6 or 0.7 or 0.8. or 0.2 or 0.3. It's not everything is random at a half. But however you develop the assignment, we're using a variable name, namely the name of the column is mom, dad, and child. We're using math libraries, count A, to count how many cells have something in them, count if to have a specific entry in that cell. And then we just calculated the ratio of those two.
Can you share your code from column 11 or column I again?
Yes.
I don't know what I'm doing wrong.
Okay, give me a second. I'm going to try to make this a little smaller so it'll show up on one line. So you and the something comma something, and that's either true or false.
Yeah.
If it's true, I made it recessive. If it's false, I made it dominant. And again, the ats are only needed because I have the newer version of Excel.
Okay, thanks. I don't know what I typed wrong to begin with. But then when it started trying to autocorrect, it messed it up worse.
You mean autocorrect doesn't work all the time?
No.
Gee, I want, it works so well on texting. Not.
Well, I have a quick question, if I
Yes.
may. So what if we want to test, let's say, a student's perception on the, basic genetics puzzle like this? For example, what if we ask a question if a child is a dominant or recessive, and then they would need to fill in the gap with either of those parents to get to the answer. Is that possible to do? Like a height? So in other words, there will be, let's say, just the mom information and there's no dad information.
Right.
And then there's a child. Or vice versa, like, going, so in other words, going backwards, instead of going forward here, going backwards and
Right.
like,
So going backwards, if one of these is dominant, you can't tell why, from this calculation, you can't tell why it's dominant. Is it dominant, dominant, recessive, dominant, or dominant, recessive? All you get is the gene expression of dominant.
right. But if we're given one of the parents, for example, so
Yes.
once, let's say students want to make sure that they understand this, like a, semi-Punnett square idea, so to speak.
Right. So you could ask the question, if the child is dominant and one of the parents is dominant, what can you tell me about the other parent?
Right. There's
And
two
the answer-
possibilities, right?
The answer is two possibilities. It could be either.
Right.
If the child is recessive and one of the parents is recessive, then the other parent has to be recessive
Right.
in this model.
Right.
But
But what I'm
that's
saying is,
compared to real genetics.
What's that?
That's simplified versus real genetics.
Yes, but
You build this out for all four, so having both genes from each parent.
right. So you could make it as complicated as you want. The key thing is you're going to do some combination of ifs and ands and possibly nested ifs or nested ands, depending upon how things are going.
right. But I think maybe I misstated my question. Instead of having the actual answer in column, for example, in column H, if we look at the line 10, G10 and H10,
Right.
if that would be a blank. So in other words, if I want the student to actually come up with the answer instead of seeing the answers,
Right.
so would that not be possible in the Excel? To,
Well,
let's say, if
if-
the question, if looking at the child's, for example, genotype that we have in
Right.
column I square I10, and we know that in G10 the mom is dominant. Fill in the gap. So it's not possible to achieve an Excel.
You
without
can, but
always-
you have to be a little tricky on how you would do that.
Okay.
Um,
So it's a little bit more doing. I thought it was just a simple like masking that info.
Well,
As you can tell, I'm not an Excel heavy user at all.
yeah, you could possibly um, let's see. Yeah, the only thing I can think of is you could. So I just printed it in white text. So do you see anything in column H?
No.
Okay. So,
That is interesting. Yeah.
so let's say this is the kid's answer.
Right.
Now, the problem is I don't know how to do two different possibilities.
Oh, okay.
I mean, if it's recessive, I could type in recessive as the guess. And then I could say if this equals that,
That is correct.
true, you know, well, I'll just do ones and zeros. So, but for the case where there's more than one case, I'm not sure I can figure out a simple way to do that.
Right. All right, cool. That is a great start. Thank you so much. I appreciate it.
But you know, there's other kinds of things that you could do for random walks or sampling of different things or spinners or others that are just binary choices combined with other choices. What can you get? Let's try another one and then we'll take our second break and come back and do a final thing. Just to give us a clean workspace, I'm going on the dice page and I'm blowing that up. This used to be much more controversial than it is now. For many, many years in North Carolina, we were not allowed to teach about dice in the classroom of K-12 schools. We could only teach about number cubes. And so we could have a cube that had the numbers 1 through 6 on it, but we couldn't use the cube that had the 1 dot, 2 dots, 3 dots. You know, it's amazing. Anyway, suppose you wanted to simulate a cube. There's lots of ways you could do that, but what would have to be the result of a 6-sided cube when you rolled it? What would you expect to get on any given roll?
A number between 1 and 6.
Right. So there's lots of ways to do that. One way is to do it just like we did the coin flip. We could say if a random number, well, actually, we have to roll the dice first, so we can use the same random number. So I'm going to say equals rand. So that'll be our random number. That'll be our dice. In fact, I'm going to call that dice. Then we could say equals if, again, you either use or don't use the @ sign, is less than a 1/6, I'll make it a 1. What if it's not less than a 1/6? Then if the dice, the same dice, is less than 2/6, I'll make it a 2. Well, what if that's not true? Then I could say if the dice is less than 3/6, I'll make it a 3. Well, what if that's not true? Then I could say if the dice is less than 4/6, I'll make it a 4. Well, what if that's not true? Then if the dice is less than 5/6, I'll make it a 5. And if it's not 1 through 5, then it has to be a 6. That's one way to do it. Now I need some more closed parentheses. So what you can see is I can split up the numbers between 0 and 1, and depending upon which bin, which pocket it's in, I could get different rolls of the dice. And if I pull this down, so you should see 1s, 2s, 3s, 4s, 5s, and 6s.
Can you just copy your code into like C so that it stays
Yes.
or into the chat box?
Yep.
You type faster than I do.
If I do it in the chat box, it'll be easier for you to copy it. I hope. Send to everyone. Now, there's an easier way to do that, which involves a computation rather than a binning. And that is, you can take the numbers from 0 to 1 and spread them out to be between 0 and 6 and take the integer part. So if I took the integer part of 6 times, and I want to use the same random number, and then I add 1, can you see that if I take the number of sides of the dice, multiply it by a random number, and then truncate that, I'll get between 0 and 5. So if I add 1, I'll get between 1 and 6. And I'll put that in the chat window also. Now, Juan Lee was saying that he always, or he or she always is missing one of the parentheses. One of the features that was added a couple of years ago to Excel was a very subtle color of the parenthesis. Do you see how we have gray, green, something, red, black? So what I was doing is I was adding parentheses as long as the color was matching up. But I like Aaron's suggestion of typing the parentheses first and then typing what's between them every time you add one. But can you see how this algorithm is perhaps easier to explain based on the paradigm of the coin flip? If you're not less than 6, then you're going to be greater than a 6. But if you're not less than 2, 6, if you're not less than 3, 6, 4, 6, 5, 6, then you must be a 6. Or you can just spread out the numbers. This was probably going to be a lot easier if you had a 12-sided dice. Like if you said, this is the integer value of 12 times the random number, then you'll get all the numbers between 1 and 12. So you could do a Dungeons and Dragons dice. So it's the number of choices plus the lowest value times your random number, which goes between 0 and 1. So again, I think it's important for students to realize that there's more than one way to solve a problem. And sometimes knowing a little bit more math. This again is y equals mx plus b. It's kind of a linear spreading of the values between 0 and 1 and then mapping them to the values 1 to 6. I typed an extra character. And again, this would be any other sided dice. Now, what was very confusing when we did an experiment at Clemson is we asked the students to calculate the distribution of values that they would get. Okay, there's a question. Can I explain why we add the 1? All right, so let me do that here. I'll not add the 1 and I'll not take the integer value. Okay, so can you see the number is 5.4, and if we truncated it, we'd get 5. At this point, we would get a number which is so small that the leading integer is 0. So by not adding 1, but taking the integer value, we're only getting the numbers 0 to 5 as the leading integer. Does that make sense?
Yes.
Okay, so you can do it two ways. You can either add 1, and now the leading integer will be 1 through 6. And then you take the integer value to chop off and you can add 1 before or after the integer. It's your choice. Does that make sense for that?
Yes, thank you.
Okay.
I'll just add another way to visualize it is if you're starting with a range from 0 to 1, then multiplying that makes it wider, it stretches it out. And then adding to it, shifts the whole thing left or right. So you start with something from 0 to 1, multiply it by 6 to stretch it out 6 times as wide as it was, and then add 1 to shift the whole thing.
Now this only works perfectly because numerically, the algorithm to calculate the pseudo-random number does not allow you to actually get the number 1. Does that make sense? Because if you could get the number 1, then you could actually get a 7 on a 6-sided dice with this algorithm. But because the random number can never be entirely 1, then adding 1 and cutting it will give you the range you're looking for. Okay, why don't we take a break? When we come back, we'll do 2 things. We'll roll 2 dice and we'll talk about iteration, recursion, and manual computation. So it's 15:22 in the East. Why don't we come back at 15:30 exactly? And we'll go over some more randomness. We'll roll 2 dice. We'll play a game of darts. And if there's time, we'll do iteration. If not, that'll be the first topic for tomorrow. So I'll stay here if there's any questions or getting caught up on anything or comments that you want to make?
I'll just mention what I posted in the chat. There was a question earlier about if you're using numbers on Mac and you want it to recalculate the entire workbook. It looks like if you copy and paste any single cell onto itself, so like you could take a blank cell, copy it with Command C, then every time you paste with Command V, it will recalculate the entire workbook.
Aha. This, my friend, is what we used to call a kludge. I don't know if they still call it a kludge. But it works. I'll try it. Okay, as soon as Aaron gets back, we'll start back up. Aaron is back. So I'll preface this with a little history lesson. Years ago at Clemson, as a simple exercise, we thought after teaching them to roll one dice, we asked them how they would calculate the rolling of two dice. And apparently there were a number of kids in the class that had never really played dice games because a substantial fraction of the kids submitted a program in which they uniformly picked a number between 1 and 12. And we said, wait a minute, what's going on here? You can't, first of all, when you roll two dice, you can't get a 1. And so they said, oh, it should be between 2 and 12. We said, yes, the answer should be between 2 and 12, but not equal probability. Oh, sure. You know, you could get 2, 3, you get any combination. Yeah, but not with the same probability. And they wouldn't believe it till we had them build the combination of roll one 6-sided dice, roll a second 6-sided dice, and add the 2 and see what you get. And some of them were shocked that you got more 7s than anything else. And we had to go through the entire high school probability lesson of how many different ways can you get a 2? There's only one way, a 1 and a 1. How many different ways could you get a 3? You could get a 2 and a 1, or you could get a 1 and a 2. How many different ways could you get a 7? A 1 and a 6, a 6 and a 1, a 5 and a 2, a 2 and a 5, a 3 and a 4, a 4 and a 3. So there's 6 ways of getting a 7, but only one way to get a 12, only one way to get a 2. So in the world of sandbox dice, I'm going to leave my single dice experiment and starting anew. I'm going to roll one dice and I'm going to use the simpler formula. I'm not a very good typist. And I'm just going to directly calculate a random number. And I'm going to do that twice. And then I'm going to add the 2 to get the total. Then I'll copy that down. And I don't know, so 400 different data points. Now, I guess we could visually inspect this and see that we're getting sevens, 10s, you know, but we could also statistically use another tool that's made for doing these kinds of things. And that is the histogram tool from the Shodor Interactivate is a great way to do this. So I went back to the talk, I clicked on histogram. The histogram loads up. And then I'll clear the data. Yes. 2 dice. and I pop it in there. And the interval size is 1. The minimum value of the axis is 2. Oh. Let's see, maximum value of the then we'll kind of come over here. But and what you can see is that there's a distribution of the ones that are 2, 3, 4, 5, 6, 7. And if we went back to our spreadsheet and calculated it more, what you can see is you get different values depending upon the number of times that you've done the experiment. But you can see it's not a uniform distribution. You get more 7s and then 6s and 8s and then 5s and 9s and so forth. But you literally just build the simulation by building the simulation. You ask the question, what do you get if you know, and if I recalculate the entire simulation again, copied all of the numbers here, and then went back to the simulation. Now we've got twice as many values, and you can see that now you're getting more 7s than anything else. So you just have to, once you learn how to make a little atom or molecule of a simulation, then you can go back and do other things. What I'm going to do on my Excel page is I'm going to go back to the fun with almost pi, and I'm going to create a new simulation which is based on the following idea. I'll draw it out for you on my iPad. Suppose you had a square, and inside the square was a circle, and I apologize for my bad artistry. And let's say the radius of the circle was 1. So if I want to calculate the area of this circle, if the area of the circle is pi r squared and r is equal to 1, then the area of the circle is pi. If I was picking random numbers, and all the random numbers in the x direction were between 0 and 1, and in the y direction were between 0 and 1, some of those points would land inside the circle and some would lie outside the circle. The ratio of the circle, which is pi, to the area of the square is pi over 4. Because if this is 1 and this is 1, then the square, the area of the square is 4. The area of the circle is pi. So if I took random darts and threw them at this square so that x went between 0 and 1 and y was between 0 and 1, then if x squared plus y squared was less than 1, then I know I'm hitting the circle. And so you would think that the fraction of points that hit the circle compared to the square should be pi over 4, the ratio of the area of the circle to the area of the square. So before we go any farther, does everybody understand what we're going to simulate? Okay. Did I answer the histogram question?
Yeah, I think so. It was just asking if you could zoom in on the web page a little bit when we were on the histogram. But
Okay. We'll stop that. And is there a part of the histogram you wanted to focus on?
I think it's hard to read the text in the default zoom setting, so I think we might have just missed which boxes you were putting.
Okay, so there's an interval size, which I set up a 1. And then the minimum value of the x-axis. There we go. I've pumped up the browser size. Does that make it clearer?
Yes, I think so.
Okay. And again, there's a link in the talk slides to this that you can pump it up on your own page if you want to. Okay.
And Bob, I don't know if this would be helpful. There's a JavaScript version of the thing we're doing now with throwing darts, which might help with sort of visualizing what we're trying to do.
Okay. So I'm going to try to visualize it actually using Excel. Be the goal. But yes, the already programmed by Aaron Weeden approximate pi version is there. But the idea is that you have a dartboard and you're throwing darts, and each X and Y value can go between 0 and 1. And so what you're actually doing is calculating the probability that you hit the circle versus hitting the square. And the ratio of the number of times you hit the circle to the number of times you're within the square is pi over 4. So 4 times that number should give us an estimate of pi. And so in our Excel almost, or playing with almost pi, fun with almost pi, what I'm going to do is I'm going to ask if a random number squared plus a random number squared, so that'll represent X and Y, is less than 1, comma, then I'm a 1, I'm in the circle. Otherwise, I'm not in the circle. And then if I do that a bunch of times,
Can you put that in the chat box again?
yes. So this is what I meant by taking the definition of the circle, which is x squared plus y squared equals the radius squared. And since it's the unit circle, I think I hit an extra key. So what I'm going to do is I'm going to add up everything that's in column R. I'm going to count how many throws I did in column R. And then I'm going to calculate 4 times the ratio of the number of times I was inside the circle versus the number of times I threw the dart. And I'm not saying this is going to give you a 6-digit calculation, but can you see that it's pi-ish? And if we came down here, Aaron, are you seeing the delay on the numbers filling in?
Yes.
Okay. That's what I was talking about. Is from a pedagogical point of view, an interactive dynamic program shared over Zoom ends up having a built-in delay. All right, let's go to somewhere near 1,000. That should give us a 2-digit or a 3-digit estimate for pi. So again, we're taking advantage of the fact that we can pick a number between 0 and 1. I can pick one of those for X and square it. I can pick one of those for Y and square it. If I'm inside the radius, I hit the circle, otherwise I didn't. And the result gives me an estimate for pi. And what Aaron put a link in there is one that actually, I assume it's the one where you visualize the actual dots hitting the screen and you see it fill in.
Yep.
So again, in terms of what we've been able to do so far before we kind of change and do one more iteration of things, is we've talked about variables and the value of cleaning up a spreadsheet to replace the $J, $32 notation with cats or dog or dice or mom or dad or child. We've learned how to assign variables. We've done both straightforward if statements and nested if statements. We've done things with random numbers to flip a coin, to analogously flip a coin and have it represent genetics, to pick a random number and have it represent the spread of the rolling of 6 different choices instead of a coin with 2 choices. We simulated a dart game. We looked at the only control we really looked at was the scroll bar or the slider bar. We've done some conditions and branching. We've also done some things to look at the numerical computing issues that come up where something could be hidden from us because of formatting. There's actually a subroutine inside of Excel and every other spreadsheet that takes binary numbers and turns them into base 10 numbers. And those numbers turn out to not necessarily look like we think they are. And sometimes Excel even physically changes the number and tells us it's 0 when we know it can't be 0, or tells us it's positive when we know it should be negative. Those small numbers can vary. So what I'd like to do is if you want to, you can use the next 10 minutes to fill out the surveys. Did Aaron put up another link to the Google page that has everything on it?
I haven't yet, but I will do that in just a moment.
At least everybody that's on now will get the Google Doc again. So the Google Slides, the HTML link and the Google Slides are at the top. There's a daily survey on Tuesday that we would ask you to fill out today. There'll be a separate one for tomorrow. And there's some information on workshops that are going forward. Now
Sorry, go ahead, Bob.
I was going to say that usually Aaron has some closing remarks per day.
Yeah, I was going to mention for the surveys. So this workshop is sort of being co-hosted by both Exceed and Nixie. And both projects have their own set of surveys and data collection and analysis. So that's why we asked you to register on 2 different sites, so that both projects can keep track of who's attending and getting the survey feedback for both. If you are interested in receiving a stipend for participation in this workshop, I've sent a few emails explaining who's eligible for that. And one of the conditions for receiving the stipend is to take all of the surveys. So you should have gotten an email from me with links to the pre-survey. If you're going to take the Nixie surveys, you'll need to first register for this workshop on the Nixie website. And all the surveys that you'll need to take are linked in the Google Doc. If anybody's having any trouble accessing those, please let us know. We can help. These will be a big help for us for planning future workshops and reporting on the impact we're having with the ones we're doing now. And we have you do a pre-workshop survey and a post-workshop survey so we can get an idea of whether this workshop is helping people learn something.
Right. So just informally, in terms of questions, comments, and concerns, is what I tried to cover this afternoon. I know I crammed a lot in 3 hours, but was it substantially new or memories of past lessons? Our normal experience is that people that have learned how to use Excel to make XY graphs never get to see the computational computer science lessons that could be learned by really lifting up the hood and figuring out what's going on with Excel.
This was great. I've done some powerful stuff in Excel, but you always have to look up everything because I don't do it often enough, but this was outstanding.
Okay. And it's not my job to apologize for Excel, but they do keep changing it every 18 months to 2 years and stuff. The syntax changes, the layout changes, the functionality changes. There's apparently fights at Microsoft between the GUI group and the numerics group, and they're blaming each other for the fact that it's now running so slow compared to older versions. But it's still a useful tool. And what I find at a liberal arts college like Wofford is a lot of kids have the expectation that they're going to graduate knowing how to use Excel for business. And when they learn how they can use it for business modeling or physics modeling or chemistry modeling or biology modeling, they're in a much better position for graduate school. Any questions or comments or things you, rather than trying to start a new topic on iteration and recursion, I'm going to save that as the first thing we do tomorrow.
No,
Did-
Bob, everything is cool and clear. Thank you so much. Just one thing, I'm actually posting this on the survey. If you would have the formulas for Excel, like kind of on a separate spreadsheet or something that we could copy paste, that would be great. Otherwise, it's kind of a little hard to follow sometimes. That's the only. Other than that, that was awesome.
Okay. Was pasting it in the chat window helpful?
Yeah, when we like requesting it, when we asked you, yeah, you did it. That's fantastic. But it would rather like, not to have you kind of a stop and maybe interfere with others who are actually going ahead.
Okay.
Maybe it would be better to have everything. And another question is, are you guys going to post the recordings of the session by any chance? So in case we
Yes.
need to review some? Okay, excellent. Fantastic. Thank you.
It's not going to be immediate because it has to be post-processed.
Oh, yeah, sure. Absolutely. Yeah, definitely. But as far as like, going back and check, there are definitely really cool examples as far as engaging students instead of just showing them, like you mentioned, $sign and this, which gets fairly confusing. But when they actually see the principles behind that, that is a much clearer, aspect to educate students than just $signs at this column, that column.
Right. And we have seen evidence that kids that go through an introduction to programming concepts before they're actually learning Java or C star or Fortran or high performance Fortran or MPI end up doing better when they get to a programming language because they understand the basic idea of what's going on.
A question. For a lot of your formulas, you use like B column B because you're talking about the whole column,
Right.
and that makes sense. But I would find it helpful to be able to label the very first, row 1, like number of times I rolled the dice, or
Right.
If I do that, then I don't have the whole column as data.
Yeah, but you have the whole column -1.
Right, but for example, for the genetics, dominant, recessive, so it was mother, father, child.
Right.
Straightforward for me to remember, but as the examples get more complex, I would like to be able to label the first row mother.
You're
father,
right. I was using a shortcut, and you can do that. Just to remember, when you count how many things are in the column, you subtract 1 for the label.
Okay, all right, that's what you meant. Okay.
Yeah, the thinking human being says, Excel counted every cell that had something in it, but I know the first row shouldn't be counted, so I'll subtract 1.
And when I do something like, if I want to add every value on column B, will having text return an error message?
It might. There is an alternative, which is if you have a column notation like B:B, and you only want to do starting at column 2, or sorry, row 2, you can say B2:B, and that will start at row 2 and go for as many rows as there are.
Rather than counting all of them.
Yeah.
Yep.
Great, thanks.
Good point. Like I said, there's more than one way to get to the answer, and you can make it as clear as you want. I mean, there's actually a feature in Excel which math people like, which is there's a little click box in the preferences that you can make it row column instead of column row. If you're doing matrix, you want to teach matrix calculations, it's always row column notation. And so you can make it row column instead of column row. So I mean, and it's just little, and you got to be careful because it's a little checkbox that if somebody goes into a lab and checks it, they're going to mess up the next kid that sits at that computer. if you have shared labs. Those are all good suggestions, and I can make the examples clearer going forward.